All right, let's dive right into this explainer. Today we're exploring a massive foundational shift in how we think about saving data. We are talking about the event sourcing design pattern. And look, this pattern challenges one of the most deeply ingrained habits we have as developers, how we interact with our databases. For decades, we've just naturally treated our databases as a single source of current truth. But what if that approach is actually destroying the most valuable information your application generates?
Imagine your database capturing every single change as an immutable event that you can literally replay. Think about how source control works, right? With Git, you don't just save the final version of your code. You save the diffs, the commits, the entire messy journey of how that code came to be. Event sourcing takes that exact same philosophy and applies it directly to your application state. Instead of quietly overwriting its own history, your database basically becomes an append-only audit log.
Section 1. Rethinking your database. Moving beyond basic CRUD.
So let's look at the traditional way we store information. CRUD operations. Create, read, update, delete. They're heavily optimized for ensuring the current state is correct. But think about it. Updating and deleting are inherently destructive acts. Let's use a shopping cart as an example. Say user A adds 5 items, removes 2, and checks out with 3. Meanwhile, user B just adds 3 items and checks out instantly. In a standard CRUD database, their final rows are completely identical. You've completely lost the insight that user A hesitated. But in an event source database, it records the full journey. Cart created, item added, item removed, checkout completed. The entire behavioral history is preserved.
Functionally, event sourcing is a persistence pattern where every single change to your application state is captured as an immutable event, and the current state is derived just by replaying those events. And hey, if you want to try this out in Python without building all the plumbing yourself, you absolutely have to check out John Bywater's event sourcing library. It's a fantastic package. It handles the storage, the replay, the orchestration, all of it. And it works whether you want to back it with SQLite, Postgres, or even wire it into Django and SQL Alchemy.
Section 2. But isn't it slower? Tackling the performance myth.
I know exactly what you're probably thinking. Replaying all these historical events from scratch on every single read, that has to absolutely wreck performance, right? It sounds like an incredible bottleneck. While Python developer Chris May hit the nail on the head when he said, "It turns out computers are fast." According to experts like Martin Dilger, for event streams under roughly 2,000 events, querying the event store directly and replaying the state takes mere milliseconds. Modern compute power and standard database indexing handle that volume effortlessly.
Okay, but obviously, you will eventually hit scale. Or maybe you just have specific views that need to load instantaneously. The crucial point here is that we don't actually have to replay events from scratch every time. We can use a pattern called CQRS, Command Query Responsibility Segregation. It's a mouthful, but the concept is brilliant. You separate the write side, where your immutable events are appended, from the read side, which is essentially a fast read model that gets incrementally updated. It's a projection tailored exactly to what your UI needs to display.
Because you've separated your reads from your writes, you unlock this incredible optimization menu. Event sourcing gives you massive flexibility. Want in-memory caching? Layer in Valkey or Redis. Need to push live updates to a front end? Hook up Nats. If you want to keep your infrastructure super simple, just use Python's disk cache locally. You can even use MongoDB to atomically update both a computed status and the event array in one single go. The point is, you aren't locked into being slow. You have options.
Now, what about storage space? Won't this just grow infinitely and eat up all your hard drives? Well, to prevent storage and replay times from growing forever, you use an accounting technique called closing the books. It's just like a retail store tallying up the register at the end of the day. You omit a summary event at a natural boundary. Then, future replays only need to read that one summary event plus whatever new events happened today, rather than replaying everything since the dawn of time.
Section 3. The AI coding advantage. Why AI loves this architecture.
Let's look at a completely unexpected benefit of all this. Event sourcing is basically a cheat code for working with AI assistants. There's a documentation technique called event modeling diagrams. It's this very reduced visual language showing events and commands over time. And it turns out, AI models read these diagrams remarkably well. Experts like Martin Dilger and Adam Dimitruk have actually run research spikes where they record a client transcript, use AI to generate the diagram, and then pipe that diagram right back into an AI. The result? It generates roughly 85% of a working code base in hours instead of weeks. Insane, right?
The reason this works so seamlessly is purely structural.
Event sourcing encourages something called a vertical slice architecture, where you group code by feature with well-named domain events. This is absolutely perfect for an AI's limited context window. Chris May noted that at his company, where AI coding is mandated, tools like Claude Code perform dramatically better inside their event source services compared to traditional CRUD ones. The AI doesn't have to scan hundreds of unrelated files to figure out what's going on. The coherent, event-driven slices tell it exactly what it needs to know.
Section 4. When to make the switch. Heuristics for adoption.
Look, event sourcing is amazing, but it isn't a silver bullet for absolutely everything. So where do we draw the line? Well, if your database table relies heavily on a status column, that is a massive red flag. It means you aren't doing simple CRUD anymore, you have complex state transitions. Use event sourcing. If you need ironclad audit trails for compliance, or you really want time travel debugging, use event sourcing. But on the flip side, if you're just building a simple forms over data contact page, please, just stick to CRUD. And most importantly, if your development team isn't totally bought in, do not force it. A complex architecture that half the team is actively trying to work around is a recipe for disaster.
If you do make the switch, be prepared. You need a solid plan for schema migrations. You can't just run a casual SQL alter table command anymore. You manage schema changes using strategies like default fallbacks, where your code just gracefully ignores missing fields. Or you can use something called upcasters. These are small, localized functions that transform version 1 of an event into version 2 on the fly, exactly when it's read. And if things get really messy, you have the nuclear option, writing a script to transform and copy the entire event store into a brand new database.
So why go through all this trouble? The ultimate payoff is realizing that your database holds a perfect historical record. Chris May shared this amazing story where a sister team asked for his services data for BigQuery. They were expecting maybe 3 days of logs. He handed them months of perfect behavioral history on day 1. When his boss asked for a 30-day report, he wrote a quick script against the event store and instantly had a populated 30-day chart. Being able to answer questions you didn't even know you'd be asked, or time traveling through bugs to find the exact event that caused a crash, as Chris says, it's intoxicating.
It completely changes the kinds of questions you are even allowed to ask about your own application. So, the next time you sit down to architect a complex feature, take a step back. Ask yourself, is it time to stop overwriting yesterday's truth? Think about the insights you might literally be deleting right now. Are you ready to let your code base be honest about its own history? Give it some thought.